Hey yo, what's up? It's your boy, a J, a O, a S, a H, a A, a B, a R, a A, a H, a M, and we're back with the sequence analysis, and we're doing the nucleotide. Forgot the name. Nucleotide transformer model. Yeah, and yup, looks like the table looks like the sequences are labeled. Not gonna lie, I'm a bit confused on how do I submit this assignment. You know what I'm saying? How does that work? How do you submit this? I mean, we got all the intro instructions and shit. Ah, your code here. File extension. Correct. The output means exercise 22 is now at the embeddings generated stage. What just happened in concrete terms? You had 1,320 DNA snippets from the dataset. Each snippet was passed through the nucleotide transformer for each DNA sequence. The model produced a 1280 dimensional vector and embedding. These vectors were saved to disk together with their class labels. Now, so you have x equals the embeddings and 1320 virus class for each embedding. That warning should probably train this model is irrelevant here. Your next required step is linear probing plus T as an E, which means use the embeddings as input to simple classifier logistic regression or linear layer to predict virus type. Use TSNE to project the 1A to embedding down to 2D and visualize. Okay, that part is visualizing, okay? If you want, I will give you an exact next step .py file, okay? Okay, so is the next step, but I should have a new .py file for this. If yes, give me a name also for that. Will do load the save NT. You are now at the stage where biology, numbers, and machine learning happens. Okay. So I do remember the last time we did this for exercise 21, the what? The what? The embeddings were not kind of saved for the next .py file to read, but I'm guessing that won't happen here. Or do we need to make that change? Also, I have made the tsne.py file. You already did it correctly. Next to the embedding. It's exactly the structure like this. NT transformer, NT embedding star PT. You already created this. Put this. Let's see. It should work. Right? What this will give you after running, you will have a number like this means 92% of the viral classes can be predicted from the embeddings alone. How do you even know that number is going to show up, bro? A file. This shows how different viruses cluster in embedding space. If the clusters are clean, the transformer learned biological structures. You have now completed the full pipeline. So this should visualize this. I don't know. I don't think it's gonna work in the first try. Yeah. I told you there is no such file, bro. This is what it gave me. Find the line, touch, save. It will look something like this. This is the last lines from 40 to 43, 45 in transformer embed.py. But the linear probe fix stack change. Open, replace this line, data torch.load. Okay, with then update it to the rest of the file so it uses embedding. For example, if you had for the linear probe TSNE, what exactly should for the x and y. Connected. In the data dictionary, you loaded two tensors directly, so line become. That is only the correct replacement. Okay. I could give replace your loading section with this. Okay. At the start, there's a lot important. Your script is almost correct, but it will crash the same reason as before. Embedding is a list, not a tensor. You must stack it. Okay. So it should work now. Right? Nope. Attribute error. List objects has no attribute CPU. Not tensors, so the dot CPU does not exist for either. Is there another XY? No. I'm making these changes a lot. Okay, now it looks, I think it looks good. Accuracy 1? That's not good. I don't know how to feel. You trained and tested on the same data, so the classifier memorized and embedded instead of learning generalized patterns. That's very common in linear probes if you're not using separate test set. Embeddings are very informative. NT transformer embeddings so maybe so good that sequences from different virus classes are already separated by. Okay. Is it done or is it still working? And I did get a sort of graph instead of matrix. And do you know how proceed? Yes, it's done. The terminal output shows the embeddings and labels were loaded. The linear classifier ran. It printed accuracy. What it means how to proceed is each point is a DNA snippet colored by its virus class. So looks like this thing. That's about 3. Mhm. Save the plot if it's already not saved. Optionally, notate the clusters to check which labels correspond to which cluster using class name to make it interpretable. You can also report the linear probe accuracy with the write-up. Even if it's 1, you can explain that it's because the probe was evaluated on training data. Okay, so I need you to make to add the part where it saves the PNG graph for future Yep. Okay. Is there how to submit? I'm still confused on submitting. From the notebook content you shared, there's no mention anywhere as a medium. I got 1 hour before I submit. I got about 4 Python codes. Is that mentioned here? Train. Let me see those files. Baby, I'm right here. CSV file. I have a CSV file. What app? Xcode maybe? Okay, copy, bro. How do I open this file? Why is it flickering? Okay, so I should be. So it's better if I upload .png, .csv, and .pt files of each assignment. But that's what? I have to submit the assignment within 1 hour, but the check mark is in. Okay. Okay. Hmm. Think. Uh, mm, mm, mm. So, bum, bum, bum. And why is there two dot pt, and I'm guessing they both are important. Train NT embeddings contain the actual embeddings of your DNA sequence from NT nucleotide transformers. These are the feature vectors that you use for linear probing or other downstream tasks. Train NT label contains the labels corresponding to each embeddings. Without these, you cannot train or evaluate the classifier. Yes, the both.p files. Mm-hmm. So compare to EXC21 and EXC22. It seems EXC21 has .pt, .csv, while the EXC22 don't have a CSV. Also, I'm a bit worried on the linear probe accuracy being 1. I think that's it. Yes, that's correct. The file types differ slightly because the exercise because between the exercise because of what each one is doing. Exercise 21 protein ESM2 dot pt embeddings of 17 protein sequences. Dot csv save the cosine similarity matrix in csv for reporting later. Heat map embeddings of DNA sequence, labels for each embeddings, the TSNE plot. No CSV strictly required here because you are in computing a similarity matrix that focuses classification and visualization. Mm-hmm. There's a lot of stuff to compare. Okay, I'm gonna submit it and bum, 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 bum. Save selection. Brother. Okay, I just submitted that. Now I gotta do my gender studies assignment. God damn, son. A lot of shit to do. After gender studies, I need to figure out my money. Well, peace out, YouTube. It was a good run. Don't worry, we will be coming back to this because this is just submitting the assignment. I need to, because I still don't know a lot of these terms, a lot of these stuff, a lot of matrices. What does it mean? How can we increase the accuracy? How, where, what, which part we need to change so we get the required accuracy? I don't know. I need to figure that out. A lot of shit to do. Peace out, YouTube.